in radial distributed system using the genetic algorithm. So in this system, basically we need to develop. I have developed the complete distributed generation of the power used in different stations, grid stations, like the difference between demand and load leads of several problems like the outage, poor power quality, even sometimes to black out the system. So we need to introduce the genetic algorithm which will reduces the losses of power during the distribution generation. So this is the abstract. I have written the abstract, and then is the introduction. So this complete structure is developed for Indian power scenario. So in the Indian power scenario, we have just added the generation capacity till to 2013. Okay, so these are the capacity we need in different cities, in different states. And next one is basically the demand, peak demand in 2012. So these are the demand, and the demand depends on step by step. So after that we need to just consider the next part is basically project installed capacity requirement as well. So next part is basically the thing is that general structure of power. These are the transmission power, and the transmission power is basically the Indian structure of the power, like 33 kilovolt, 11 kV, and 240, like depend on the different grid stations, distribution, generation, transmission, and supply as well. Okay, so next part is basically a transmission is the distribution system as well. So the distribution system is classified according to different voltage levels, primary distribution systems and the secondary distribution systems. Next part is structure of distribution system. These are the structure for the distribution system. And the next part is the requirements of customers. Okay. So availability of power demand, I have added everything added in it, like the literature survey, the appropriate size according to different networks, power loads, optimization techniques, classical methods, like which the previously method used, and what I have used is basically the genetic algorithm, and what is the innovation from the previous system, and what it cover up the main major problems. Okay, so I have explained all the optimization techniques here, particle swim optimization and everything which normally used in different structures. So the distribution generation as well, like definition and everything, like to convert two bus system, two bus distribution system with distribution generation according to different load sizes as well. Okay, so next one is basically, yes, distribution delivery only. These are the types of distribution system I have explained here, and the advantages of distribution systems, impact of distribution generations, and power quality accordingly, protection system, power flow of radial distribution system, and next part is nonlinear ladder network. Basically, these are the ladder networks used for the different power structures used in it. Okay, so these are the flowchart I have developed for the rate line and load as well according to different power levels. Okay, so next part is basically the optimal setting and sizing of distribution generation in radial distribution system, what's the problem? Problem is basically we need to identify the large distribution system, and we need to we need to find out the complex optimization problem according to 11 kV radial distribution system. Objective function, genetic algorithm, explained everything, and according to the flowchart of technique as well. Okay, so the methodology, like how I have developed the complete system according to different bus levels and different bus structures. Okay, in which I have added the complete genetic algorithm for distribution generation. The results is basically based on the voltage profile for 15 bus radial distribution system. According without distribution generation, these are the tables used for the different voltage profiles, and it's the graphs as well displayed here. Okay, so these are the comparison of voltage profiles at various buses with the and without DGs. Okay, so the saving of power loss, like the power losses with DG is 17.86 kilowatt and without DG is 62.12 kilowatt. It means that we need to we have almost find out the 45 kilowatt losses to reduce the losses. Okay, so comparison voltage profiles, the tables and everything added in it, the power loss as well, so impact of size as well, all the graphs are added in it. So I have also developed the complete MATLAB code for the based on this complete structure, and it also displays the different distribution networks. Okay, so let me just show you. Basically this is the MATLAB code developed for the complete multi-object loss power loss system. So you just need to open this structure, basically. Yes, this one. Okay, so the core loss function with objective losses, when you will just when you will run the system, you will get the output like this, for example here. Okay, so this one is basically these are red dots or displayed the distribution generation at different levels. This display is almost uh, different figures accordingly, and we just need to, it means almost 22 figures basically. Okay, which displays the different power generation levels according to the distribution systems. Okay, so these are the bus numbers according to different voltage levels, like 11 kV 11 kV or 32 kV and 132 kV as well. Okay, so these are the power system. You will get the output like this. These are the outputs given in the core function with objective loss and CVD, basically saving of power. So this is the complete structure of the this complete project. If you need to ask any question, you can ask me as well. Okay, thank you.